Okay, so recently, uh, you might have seen it. Apple released a paper talking about how LLMs can't really reason and how that is like something profound and that they need to prove it, which does not really make any sense to me because it's so simple to understand that they don't reason and that they can't reason because of their design. I made a video 1 week and a half ago about how they can't decide, how they can't make an action, and the reasoning as to why. Oh, I'm the same spot as last time. The reason why they can't reason is pretty much exactly the same, in the sense that once again they're just predicting the output. Uh, what I mean is that you have the so the way that LLMs work, as a quick recap, is that you have the I'll say it in a different way. Oh, there's no way down there. So what you have at the beginning of everything, at the beginning of everything, you just have a vector space with no specialized anything. The distribution over the output space, over the token space, is random, as uniform, you can say. Like every token is equally likely to be the next token in the sequence of tokens that you're studying from. And what you do is that you bias this distribution to pick the tokens you want based on the training data that you have. You feed it texts and it sees the same sequence of words, and therefore it understands that the next token is probably going to be one of all of these choices. And the bigger the context that you give it, the bigger the more biased the distribution will be, the more correct it will appear to us to be, in the sense of it will generate the token that we expect most of the time, and it will give semi-correct responses or correct responses. It doesn't really matter. On top of that, you have the chain of thought, or you have reasoning, how it's called nowadays. You have models like O1, O3. You have like Google's reasoning, or you have Apple. No, Apple hasn't done anything. You have you have Anthropic with reasoning models, and they talk to you about how these models are these reasoning beasts that can find logical stuff, and they don't really do that. They don't do anything close to that. In fact, in most cases, the paper that Apple put out is good, both because it shows to most people that reasoning doesn't really exist in LLMs, but also because it stops the marketing. It fucks up with the idea of like OpenAI saying, oh yeah, this is a reasoning model, when it's not. It's just a more correct model, a better model, but more expensive, which is why they present it as this unique thing. Like most people don't really need it, because the stupider models are good enough. So what is this reasoning? How does this reasoning work? The way that this works is that you have the user prompt. You have the system prompt, you have the user prompt, and then as you have the user prompt, what happens is that the system prompt includes something like, at the beginning, add the think token and start doing it's not exactly this, but like this is essentially how to copy the reasoning of these models, and you can see it for yourself that it works. And say start with a think token, and then start, the user is asking me to ... and then after that you can tell it to say, okay, now refute yourself by stating this or by stating that, and then you tell it to have this like Hegelian dialectic, I guess you can say, back and forth a couple of times in order to refute itself. And okay, Hegel is wrong. There is no like thesis, synthesis, antithesis, whatever. But in any case, I'm not here to talk about Hegel. I'm here to talk about reasoning models. And what happens in the reasoning models is that this back and forth that they do with themselves effectively narrows down their capacity to be wrong, in the sense that it adds more context in the vector representation of what they're trying to say. So if you tell them to make me a to-do list in React, and then there is some implicit context there. So the implicit context is that you want a React JavaScript app that React's a framework for JavaScript, that you want a to-do list. So a to-do list has a specific structure. It's a list, and it has buttons that you click and yet that you can tick, and you should be able to add tasks, etc. This is all implicitly internalized in the LLM by its training data, and it is very often it is understood. Like most AIs, when you tell them make me a to-do list in React, will understand what is a to-do list. But what happens is that a lot of them, when you're talking to a reasoning model, what happens is that it will go through these implicit ideas of what a to-do list is, and what React is, and what this thing is, and what that thing is, and it will add this context that is implicit, will add it explicitly. The user is asking me to make a React JavaScript application, blah blah, and then so because these LLMs are autoregressive, so every time they guess a new token and they are fed the entire past of the discussion. So when you see the LLM saying hello, how are you doing, it is fed hello and your message, and the system prompt your message, and then hello, and then generates how, and then it is fed the system prompt your message hello how, and then generates r. And so it builds a conversation by constantly self-referencing what it has said before. And what that does is that it maintains context for the agent, so it doesn't go wildly around and say whatever it wants. But what the reasoning of the reasoning models does is that it reinforces this contextualization of things. So you can think of, if you want to go a bit more technical, you have the vector space, as I was saying at the beginning, that starts as everything being uniformly probable, 8 tokens uniformly probable, and then as you fine-tune the LLM, certain tokens become more and more probable via like something. Imagine a softmax, essentially. I mean, I think it is literally a softmax, but that you end up with having some tokens that are appropriate to respond with for its context, its past sequence of tokens that it has. And so based on that, it picks the token, and then for this new context, this new sequence of words, which is identical to the previous one with the added token that it picked, it then picks a new token from the distribution in the vector space, right? And so this, if you go for like, if it generates 20 tokens, if it generates 20 tokens, that creates a trajectory of 20 steps in the vector space. And this can have, each step has a region around it, which is a good choice to make, essentially. and you can have wildly varying results based on which spot in that tiny circle around a probable vector it picks, right? So if it says hello, how are you doing today versus hello, I hope you're having a good day, both are good good greetings, but one is more formal than the other. And so you have like this difference in contextual output on very small differences in the semantic thing of what this is. Yeah, so essentially what the reasoning does is that by stating explicitly a lot of things, this autoregressive behavior becomes a lot more restricted. So because it is so self-referential and so autoregressive, you end up having a smaller region of probable trajectories for the actual true answer that will come after the reasoning. So in the inside of the think tokens, so inside of the reasoning, I should cross the street, inside of the reasoning, what you end up having is that you have the agent stating very obvious things and being like, on the one hand is this thing, on the other hand is this thing, and a back and forth which effectively jumps it through the vector space. So it makes it adds more context, it adds to a trajectory, and then when it comes time to actually respond to you, it has a very pretty fixed trajectory that is more correct than if it had just started generating because of all of the previous context. And then in new generations, new prompts, it will redo this, so it will add a lot more reasoning, it will add a lot more explicit context rather than work with the implicit context that has been added because that exists because you didn't say very explicitly, very verbosely, if you want, hey, I want to make a JavaScript app and the app should do this. Because if you think about it, if you go to an LLM and you explain exactly what you want it to do, you have done it already. Like if you go and tell it, I want you to make me this JavaScript app, and you give it the exact code for the JavaScript app, I mean, then the context is extremely constraining to the LLM, but it's not of no use to you. So the trade-off that existed was that you had you want, with explicit words, make me a to-do list in React. You want the LLM to contextualize, to internalize the implicit context of what is a React app and what is a to-do list and what does it mean for a to-do list to be written in React and what is a hook in React or whatever. All of those things need to be implicitly understood by the agent. And so because people tend to be more implicit than an LLM feels comfortable or understands or can keep up with, reasoning adds that implicit context of what a React app is, because it has been trained multiple times to say, the user is asking me to make a React app. A React app is a JavaScript app that uses blah blah blah, and so it generates the context, the explicit context that is there implicitly by you, because you don't want to do it, because otherwise you might as well write it yourself. So yeah, I didn't read the paper by Apple, to be honest. I don't really care to read it. I mean, I agree with it. I don't know how they went about to prove it, but it doesn't really need proof. It is if you know how it works, you don't need to prove that it works the way that it works. So yeah, good for you, Apple, for ruining the marketing of all of the other, I guess, big AI, big tech, big firms, I don't know. But yeah, there is no reasoning. It's more prompt engineering done internally. The people at OpenAI or Anthropic, they just hired people to explicitly write out reasoning, and then they put that reasoning inside of think tokens, and then they didn't fine tune. I guess you can just do a pre-training set from scratch, like supervisedly train the whole thing with the think tokens, and then they did some UI magic, like to hide the think tokens using CSS or whatever, and that's all. Nothing really, not reasoning. It's just an output over the distribution of tokens, but you specify, you force the distribution to be narrower, you bias the distribution, and the way that you do it is that you start with a broad trajectory when you're starting to generate, and because the added context restricts the possible paths, it biases the distribution for the next tokens. Effectively, you bias it to be a bit more self-consistent because it keeps referencing the explicit context. So again, to reiterate, the two main takeaways from this video is that, first of all, LLMs simply output a distribution over all tokens, which people really don't like for some reason. I think it ruins their marketing or whatever. But the second is that they don't reason, and that what actually happens in chain of thought or in reasoning models is that they mainly just optimize a bit further the trajectory for the final response. And the way that they do that is that they just prompt the engineer themselves effectively. They generate context that is missing, and then they add that because they're autoregressive, they feed themselves with the context, the explicitly stated context that was implicitly given by you in your prompt. That's all.